Alright, so for this section 2.1, it's going to be on linear equations and two variables. And the first thing I want to get out of the way is the idea of slope and what slope is and how you can find slope of a line passing through 2 points. And let me just say that slope of a line is merely the ratio of vertical change to horizontal change. So we use m to signify slope, so m is the symbol we use to stand for slope. And the vertical change, well, vertical values are y. If you kind of take a look at these x, y planes that I've created for us over here for the next few examples, just to remind us, y is the vertical variable, x is the horizontal variable. This triangle in front is the Greek letter delta. It stands for change. So what we're going to say is this is a change of y values, let's just say y2 minus y1, over the change in x values, x2 minus x1. Very often people remember this as rise over run. Technically though, it could be a rise or fall over run. So just to kind of remind you, this run will always go from left to right. Rise can go up, fall can go down. So the way to visualize it is either you go up and over or you go down and over. And here I explained actually there are four types of slope. Either the slope is positive, negative, zero, or even undefined. Now let's take a look at these. So when the slope is positive, this is called an increasing line. When it is negative, it's called decreasing. And let me just explain what happens. So when it's positive, we go up and over because rise would signify that the second value is larger than the first value. So it's a legitimate up and over action like this. So just to show, going from one point to the next, we will go up and over just like that. Whereas in the decreasing scenario, we don't go up and over, but we go down and over. But notice when I say and over for run, you always go from left to right. Okay. What about for m is equal to 0? Well, when m is equal to 0, think of it like this. We want our slopes to be fractions always. Something over something. 0 is 0 over 1. So the top would be, well, 0, meaning that these y values would have to be the same so that there's no actual rise or fall. If the numerator is 0, then you don't have a rise or fall, you have 0 vertical change. You still have over 1 though. In fact, 0 over anything is still 0, so you still have some run. And in fact, what this represents is really a horizontal line, is what it's describing. So notice horizontal line has no vertical change, but it definitely has horizontal change. Okay. Similarly, when m is undefined, when a fraction is undefined, its denominator is 0. So a number over 0 would mean you have some vertical change, but you do not have horizontal change. So this is a vertical line, is what this is describing. Okay. And we'll see the examples of each of these over here. So there's a little bit to do. So I want to find the slope for each of these. M equals, m equals, m equals, and m equals. I didn't leave myself too much space, so let's see how we handle this. The first thing I want to do is I want to label these points by x1, y1. Remember, any point on the xy plane is an x value comma a y value. So these are both x comma y. Now the labeling I've established here, x1, y1, and x2, y2, these are going to be points on the line. So I'm labeling the first point with 1s and the second point with 2s. So the subscript here, 1, 2, those are just labelings. It's not like a power. It's not an operation. It's just a labeling on that variable. Okay, so I'll label the first one as x1, y1, and the second one as x2, y2, and I'll follow the formula. And here we go. So it's going to be y2 minus y1, so it's 7 minus 5, over x2 minus x1, so it's 6 minus 3. Altogether, this is going to be 2 over 3. Perfect. So the slope here is 2 over 3. Notice it's positive, but we'll graph each of these after. I want to find the slope algebraically first. So now here, again, we can label them x1, y1, x2, y2. I'm not going to because I want to get used to just looking at it. So y2 minus y1 is going to be 1 minus 0 over, subtracting the x's in the same order, second minus first. So 1 minus 2 in the denominator will give me 1 over negative 1, which is negative 1. So here we'll have a negative slope, so this will be a decreasing line, but again, we'll see that in a second. Here, what are we going to have on top? Let's see. Well, y2 minus y1 is going to be negative 2 minus negative 2. Over x2 minus x1 is going to be 5 minus 3. Notice in the numerator, double negative is positive. So if you change each of these to plus, because double negative is positive, negative 2 plus 2 is 0 over 5 minus 3 is 2. But remember, 0 over anything is just 0, so that's 0. Whereas over here we have something kind of similar. y2 minus y1 is going to be 7 minus negative 2 over 5 minus 5. So yes, this will be 9 over 0. It's 9 because, of course, 7 minus negative 2 is the same as 7 plus 2 because it's double negative. So we get 9 over 0, which is undefined. So let me just rephrase so that we understand clearly what's going on here. When you have 0 over a number, that's 0. When you have a number over 0, that's undefined. Okay, so now I'm going to roughly plot these. So 3, 5, let's just say, is over here. And 6, 7, let's just say, is over here. Okay, and if you connect these, you get what I established earlier as being an increasing line. You would go up 2 and over 3. Perfect. What about over here? Well, here, one of the points is, let's see, it's 2, 0. So that's 2, 0. The other point is 1, 1. And yes, if you connect these two together, you get what we've established earlier as being a decreasing line, because you would go down and over. It's negative 1, so that means you go down 1 over 1. Okay? And what about the next one? So 3, negative 2 is going to be, let's see, let's just say this is 3 and this is 5. And if y equals negative 2 is down here, 3, negative 2 is this, 5, negative 2 is this. Notice since they have the same y value, connecting them will just create a horizontal line, which has no rise, but only run, so it's horizontal, of course. And then finally here, if we plot 5, negative 2 and 5, 7, they'll have the same x value. Let's just say 5 is over here. 5, 7 would be up here. 5, negative 2 would be down below. Its x value is 5, y value is negative 2. And connecting these, of course, will be a vertical line, which has no horizontal change and only vertical change. Perfect. So now that we finally established what slope is, we can move on to the next thing I want to talk about, which has to actually do with linear equations now in two variables. So we'll see that right now. Okay, so now we're taking a look at this particular form of a linear equation in two variables. This in particular is called slope-intercept form. I'll very often refer to the acronym SIF for slope-intercept form. And it's of the form y is equal to mx plus b, where m and b, of course, are just numbers. And in particular, these numbers represent something. M, the number in front of x, coefficient of x, represents the slope of the line, whereas b represents the y value of the y-intercept. So just to be kind of clear, and it's kind of technical, it's kind of specific, I guess, an intercept is a point. So 0 comma b is a y-intercept because the x value is 0. Remember that from 1.1? Yeah, hope you do. And the y value is b. So you can't just say y equals b is a y-intercept. You have to say 0 comma b is a y-intercept. Okay? Just being clear. Great. So now, for this next example, we are asked to find the slope and y-intercept for the following equations, or I guess for the lines of the following equations anyways. And how are we going to do that? Well, for the first one, it's pretty clear, because it's already in the form y is equal to this times x plus this. So that means the slope is going to be negative 2/3 right away. And the y-intercept is going to be equal to what? Remember, you have to be careful. It's 0 comma 2. Now, the explanation of why this form works isn't too difficult to explain. I'm not going to talk about why it's true for m. We'll kind of see that actually a little shortly. But why it's true for b is very, very, very easy to explain. Notice when x is 0, well, y is equal to m times 0 plus b, which is just 0 plus b, which is just b. So y is b when x is 0. So that makes sense why b is a y-intercept. Why it's true that the coefficient of x when y is isolated is the slope, we'll see after this example. But in any event, that's the reasoning there. Okay, good. So now for the second part here, we want to find the slope of y-intercept. So we want to do what we did here, but there's a problem. The problem is y is not isolated. Y is not by itself. So just make y by itself. So how do we isolate y? Well, we solve for y. So treat 5x as a number. We want to get y by itself. So to get y by itself, first we're going to get the term negative 4 by itself by subtracting 5x to the other side. So when we subtract 5x to the other side, we get negative 4y is equal to negative 5x plus 4. You could write 4 minus 5x, but I'm always going to write the x term in front because I'm going to anticipate this form where x comes first, right? Good. So now we're going to divide everything by negative 4. And we spoke about why we have to divide everything by a number in an equation, why we can't just divide one thing only. And it's because we're really dividing both sides by the equation. This side divided by that, well, this side divided by a number equals that whole side divided by that number. Now remember, when you have a fraction of two things with the same denominator, you can add their numerators over that same denominator. So vice versa, here you can split it up. So that's the reasoning there why we have to do that. And there's no other way. So now finally we get y is equal to, well, negative 5 over negative 4 is positive 5 over 4x. Positive 4 over negative 4 is just negative 1. There we go. You know what? I almost boxed this. It wasn't asking us to find slope-intercept form. It was just asking us to find the slope and y-intercept. But now we can do that, can't we? Yeah. Let me just write it over here. Well, the slope is 5/4. Negative 1 is the y value of the y-intercept. So m, the slope, is 5 over 4. Perfect. And what is the y-intercept now? The y-intercept now is the point 0, negative 1. And let me just label that as y-intercept. And box that. Perfect. Now on to the next example, and this is by far the best and basically only use of slope-intercept form that we're going to see, graphing. The reason why you want to write something in slope-intercept form is to graph. So if I'm going to graph this, we could graph this by finding x and y intercepts, by plotting points like we did in 1.1, but no, I'm going to use slope-intercept form. So I'm going to solve for y. So first, subtract 3x to the other side, and remember, I want to sneak it in between the equality and the number. I want to write x first. So here on the left, we just get 5y by itself equals negative 3x plus 15. And now, to get y completely by itself, we'll divide everything by 5. Remember, you have to divide everything by 5. They cancel out here, so we just get y. And we get negative 3 over 5 times x for the first term. So just drop the x down, basically. You can always do that. 15 divided by 5 is 3. There we go. So we have a y-intercept of 3 and a slope of negative 3 over 5. What does this mean as far as graphing goes? Well, let's try to create an xy plane. And let's see if we can figure it out. First off, the y-intercept is 0, 3. So we go up 1, 2, 3. Perfect. That is the y-intercept. That's where the line will pass through the y-axis. Great. Now what? Well, now we're going to use a slope to get to the next point, and that's the strategy here. You start with the y-intercept, then you use a slope after the fact to get to the next point. You only need 2 points to graph a line, so we're almost there. Now we're going to go what? We're going to go up and over or down and over? We're going to go down and over. Because it's a negative slope is describing a, what I described as earlier as being a decreasing line, meaning we go down and over instead of up and over. So we're going to go down 3 units, 1, 2, 3 from this point, and then over 5. You always go over from left to right. 5 units. So we land over here at 5, 0. Plot these 2 points, connect them with a nice straight line. Perfect. And that is the graph of that equation. Great. So now we're going to take a look at something else that will hopefully describe to us why this form is true, and it'll be based on the previous formula we saw for slope, and we'll see that right now. Okay, so now the next form I want to take a look at is what is called Pointslope Form, and it is this. It's y minus y1 equals m times the quantity x minus x1. And there are two things I want to note here. First off, m is the slope, just like we're used to noting. And x1, y1 is a point on the line, right? Now, I make a key note here. Unlike the slope-intercept form, point-slope form is used to find the equation of the line given the description of its graph. Okay? So I just want to give you the big picture. Slope-intercept form, you have the equation, you get the graph. Point-slope form, you have the graph, you get the equation. That's really the difference here. Now, I said that point-slope form would explain why slope-intercept form is true, and it's because this actually comes from the slope formula we saw earlier. x2, well, it was y over x, sorry. y2 minus y1 over x2 minus x1. Notice I'm not labeling the x's and y's with 2's, only with 1's, and I'm removing the 2 from the first one, basically. So instead of y2 minus y1 over x2 minus x1, I'm just writing y minus y1 over x minus x1. Why is that? Because we're going to let x and y be a general point that we can move around, basically, so they're variables. And if we multiply both sides by x minus x1, we get exactly this. Moreover, if we were to isolate y, notice what happens. You distribute m, okay, so you get mx minus mx1, that's just a number. Add y1 to the other side to get y by itself. So you get mx plus some junk. That junk ends up being b, as it turns out. But the whole point is this actually explains why the coefficient of x in slope-intercept form is indeed the slope. So it's all logically closed. Great. All right, so now let's move on with some examples and actually see what I'm talking about when I say we'll find the equation given the description of the graph. So here's a description of this graph. We want to find the equation of the line with this slope and this point. Fairly straightforward because point slope tells us, well, first we have to label things. So I guess let's label this point as x1, y1. That's okay. And now, of course, the slope is m. So that's m. So now we can write, according to point slope anyways, our equation as y minus y1, so y minus 7, is equal to the slope, 5/3, times the quantity x minus negative 6. So now we'll just simplify and solve for y. By the way, I'm going to write my answer in slope-intercept form. That's what I want. I want y by itself. So I'm going to, first, let's see, y minus 7 equals 5/3. This is double negative, so it's x plus 6. We'll distribute this 5/3. So I get y minus 7 is equal to 5/3 x plus, well, let's see, 5 over 3 times 6 over 1 is, well, there's a few ways of doing it, but if you just multiply straight across, you get 30 over 3, which reduces to 10. And then finally adding 7 to the other side will give us our answer. Y is equal to 5/3 x plus 17. Awesome. The other way of doing this multiplication, by the way, is to say that 3 goes into 6 twice, and 2 times 5 is 10. But either way is fine. Here, it's a little different. Now we're asked to find the equation of the line passing through these 2 points. Now to do this, we need to find the slope first because point slope, like the name implies, it needs a point and a slope. Here we have 2 points but no slope, but we know how to find the slope of any line passing through 2 points. So if we label this as x1, y1, x2, y2, we can find the slope. So there's 2 steps here. First step is find the slope. So y2 minus y1 over x2 minus x1. We end up with this. Negative 1 minus negative 4 over a minus 2. Great. So what does it simplify to? This is negative 1 plus 4 over, well, a minus 2 is 6. So this ends up being 3 over 6, which is 1/2. So I'm going to write m is equal to 1/2, and I'm going to circle that. That's the end of the first step here. The next thing I want to do is I want to use this slope with one of the points and with point slope, of course. But it doesn't matter which point we use. If you want, you can literally use x1, y1, but in reality, it just kind of depends on which one is easier for you. In this case, the numbers are smaller, so yeah, I'll use x1, y1, but in reality, it doesn't really matter which point you use. You should get the same equation in the very end anyways. So if you want to check, you can actually use the other point that I'm not going to use, but you can see for yourself that you will get the same answer. So I'm going to use now point slope with this first point. So let me circle that just to show you. So we're going to get y minus the y value, which is -4, is equal to the slope 1/2 times x minus the x value 2. Okay. Distributing the 1/2 and taking care of the double negative gives us y plus 4 because of the double negative. Here this is 1/2 x. Let's see, 1/2 times -2 is just -1. And then finally subtracting 4 to both sides gives us our answer, y is equal to 1/2 x minus 5. Great, so we found the equations given descriptions of the graph. Awesome. So that was it for 2.1, and I'll see you in the next video for 2.2. See you then.